Chapter 31. Jason sat at his console watching the numbers. It's funny, he thought to himself, how you can be so tense and so relaxed at the same time. About 6 months had elapsed since that turning point conversation he had with Dennis about how they could create what would amount to a Heisenberg compensator. All of the people working on the particle accelerator were considered geeks of the first degree, so they were quite familiar with the term Heisenberg compensator, as used in various science fiction shows. The idea is that with it, matter transference, or what many would simply call a transporter, would be possible. The thing is, up to this point everybody figured it was impossible to create anything like that. The thing is, Jason and Dennis decided not to listen to them. They still hadn't told anybody what they were working on, though. Since they hadn't done the complete end-to-end test yet, they both felt it would be prudent to keep that little bit of information to themselves. They just kept telling all who asked that they were working on a new type of detection equipment to be used with the particle accelerator. While the main purpose of the accelerator was to create a particle stream for use with the Strategic Defense Initiative, Jason had designed the accelerator to also support other scientific endeavors. As he was getting ready for work, he had been preoccupied with the day's test. It was the real deal, the point when he and Dennis would see if this was really going to work. While meticulously planning out the test, he forced himself to review each step in light of how it might affect the SDI aspect of the MMPA. The viability of that technology had to be maintained at all times. As Jason sat there, he reflected on the enormity of what he had the privilege to work on. This installation was really quite remarkable. Most of what they did here involved the Strategic Defense Initiative. Back in the Ronald Reagan era, there had been a real push to get the SDI project, or Star Wars for short, off the ground. It was a pet project of President Reagan back then, but for some reason it was mothballed, absorbed, and lost to the endless bureaucracy of Washington. At least that's what the public was told. In reality, it was nowhere near mothballed. Rather, it was put under the auspices of the Pentagon and made top secret. Barely anybody who didn't work at Midway Magnetic knew of its existence, and even fewer knew how much of a role Jason played in the project. In reality, many of his theories made the whole project possible. Where prominent scientists said it would take at least another 10 to 20 years of research to make the program viable, Jason's breakthroughs eliminated that delay completely. A particle accelerator was built in Northern California, where a natural source of helium welled up from the Earth. This helium, the normal byproduct of the breakdown of naturally occurring uranium, is used by the project to cool down the superconductors necessary to operate a particle accelerator. Once the helium is compressed, the resulting liquid exists only at the extremely low temperature of -452 degrees Fahrenheit. Since the liquid is so cold, various materials, such as certain ceramics, turn into superconductors when submerged in it. Specifically, they lose all resistance to the flow of current. These superconductors are what make supercolliders possible, and the tremendous magnets in them possible, since the massive magnetic fields that are needed can only be achieved with a huge amount of current. Without superconductors, the magnets would simply melt under the weight of such current. The Midway Magnetic Particle Accelerator, or MMPA, as everybody called it, was set up to create a stream of protons which, at the right moment, would be aimed toward the primary redirection satellite hovering above the installation in geosynchronous orbit. This special satellite was designed to accept the particle stream and magnetically redirect it either to an incoming bogey or another similar satellite with the same capability. Currently, there are 12 such redirection satellites hovering in geosynchronous orbit over the continental United States, as well as 2 over Alaska and 1 over Hawaii. There are an additional 4 located in areas between the mainland and each of the non-contiguous states. The whole thrust behind the project was to make it possible for the United States to defend itself against an incoming intercontinental ballistic missile. If an ICBM is detected, the particle stream is engaged, the matter stream is redirected to the closest satellite, and that satellite redirects the particle stream against the ICBM. While the beam isn't necessarily visible, as opposed to the lasers in its Star Wars movie namesake, the effect definitely is. While there were many small-scale tests indicating the science was sound, the first full-scale test of the system involved a UGM-133A Trident II submarine-launched ballistic missile. The missile, minus an active warhead, was launched off the coast of Guam by the USS Kentucky, with the intended target being a fictional city somewhere in the middle of North Dakota. The specific target location was actually out in the middle of nowhere, just in case something went wrong and the missile actually made it to its target. In reality, though, the missile never even came close. Once the MMPA matter stream was fired from Northern California, the beam traveling at nearly the speed of light was received by the primary redirection satellite, or node. That node then magnetically captured the beam, redirected it to another node halfway between California and Hawaii, which in turn completed the redirection to a final targeting node hovering over the far side of the Hawaiian Islands. At that point, it was perfectly redirected with pinpoint accuracy to the moving ICBM target. All this happened in only 0.2 of a second. It only took 1 additional second for a catastrophic failure of the rocket to occur, well before it got anywhere near its supposed target in North Dakota. Once the beam penetrated the outer hull of the missile, the heat it generated ignited the solid rocket fuel in the tail section of the missile. Within 350 milliseconds of the breach, a jet of hot combustion gases shot from the side of the missile and catastrophically changed its trajectory. If it wasn't for the onboard self-destruction system built into the missile that automatically fires in case it goes off target, the ensuing combustion coming out of the side would have caused its own explosion. The missile sensed something was going terribly wrong and automatically self-destructed. The test was a runaway success, and in the annals of top-secret research and development, Jason was an absolute rock star hero. Too bad only a handful of people knew he was behind the technology. One of the things that success did was grant Jason a bit of latitude to pursue whatever other fields of science he chose related to the particle accelerator, so long as the missile deterrence capability wasn't compromised by his continuing scientific experiments. He was free to pursue whatever else he wanted. The only deal he made was to stay on and make sure all systems for the SDI remained in tip-top shape. In the last 6 months, he and Dennis had been working hard at constructing a device with the ability to detect and use the constant flow of billions of neutrinos coming as a result of the nuclear reactions in our sun and from deep space, which pass through our bodies every second. By being able to detect these neutrinos, they would supposedly be able to counteract the uncertainty principle put forth by Werner Heisenberg way back in 1927. The test today was to see if that was what they had done, or if they had been laboring for 6 months on an elaborate paperweight. The MMPA was a massive facility. Aside from the main ring of underground superconducting acceleration pathways that had a circumference of approximately 32 kilometers, immediately outside the east wall window to Jason's office was a 10-story chamber containing various apparatuses including the collision detection chamber, used purely for science, as well as the particle stream redirection unit, or PSR, used for the missile defense system. This chamber sat in line with the circular acceleration track, so when collisions weren't taking place, the particle streams continued to pass through in ever-increasing acceleration, approaching the speed of light. The PSR was not to be toyed with. It had to remain ready, working, and available 24/7. The collision detection chamber, though, was what Jason and Dennis often referred to as their playground. It was almost exactly the same type of chamber as the Atlas detection chamber as found at the Large Hadron Collider in Switzerland. That detection chamber was groundbreaking in that it, as well as its sibling detection chamber called the CMS detector, led to the discovery of the elusive Higgs boson, a building block in understanding the nature of mass and the universe in general. It was the main control and measurement station to the MMPA CDC, where Jason found himself now. Dennis was also in the CDC, but his station was on the Power Control Systems section. He was in charge of regulating the 17 trillion volts that powered the collider. The detection equipment of the CDC had slowly been adapted over the previous 6 months to detect the neutrinos that were the cornerstone to the theories that Jason and Dennis had been using in building their Heisenberg compensator. With the programming development having been recently debugged, power was now being ramped up in successive sawtooth steps so that with each progressive power ridge, measurements could be taken and readings could be interpreted. Jason and Dennis were connected with an open intercom. "Are you ready to proceed with the final PI countdown?" asked Jason to Dennis. "Roger. Final particle insertion countdown commencing in 3, 2, 1, mark," replied Dennis. The readout on Jason's controller station started decreasing from the starting point of 3 minutes. 2 minutes 50 seconds. Begin LH flow, said Jason. At that moment, large valves could be heard opening, which allowed the liquid helium to bathe the superconducting ceramic materials with the aim of causing the normal resistance to the flow of electricity to completely dissolve. Since one of the biggest byproducts of large flows of electricity is the heat that is generated by resistance, superconductors were used to generate the massive magnetic fields used to propel the particles with ever more speed. 2 minutes 30 seconds, min-temp, called out Jason. At this point, the superconductor magnets have achieved their coldest possible temperature. With the liquid helium existing in liquid form at 472 degrees Fahrenheit, the superconductor magnets that are bathed in it are now capable of handling the progressively increasing levels of current that will be applied to them. 2 minutes 25 seconds, beginning stage 1 power, said Dennis. At that moment, enormous relays could be heard engaging the first of the 4.2 teravolt power supplies into the superconductor circuits. The superconductors began to hum as they felt the power coursing through their veins. 4 trillion electron volts is certainly nothing to sneeze at, but when you consider that there are 4 stages of power, each with its own supply of a little over 4 trillion electron volts, in the end, a total of 17 trillion electron volts of power was to be used. To Jason and Dennis, it was not unlike riding a thoroughbred when the system was brought up to full power. Stage 1 power ridge. Mark, injected Dennis. It only took about 10 seconds for the full complement of 4 teravolts to be achieved. 2 minutes 5 seconds. Beginning stage 2 power, said Dennis. Again, more relays engaged. Stage 2 power ridge. Mark, replied Jason. At this point, they were already consuming enough power to supply enough electricity for quite a decent-sized city. Before it is over, they would be using enough power to light up about 150,000 average homes. 1 minute 45 seconds. Stage 3 power beginning. Now, said Dennis. As the new level of power began its injection, you could really start to hear the various parts of machinery begin to hum. That is, if you weren't wearing hearing protection. Everybody was, though. Stage 3 power ridge. Mark. 1 minute, 25 seconds. Final stage power, said Dennis. Stage 4 power ridge locked, announced Jason. Power staging complete. Beginning proton stream insertion. At this point, a relatively small bottle of hydrogen supplied the protons that began their continual acceleration. Round and round they went around the circumference of the particle accelerator for the next minute and 15 seconds, until they were going so fast that even though each trip around the loop was about 32 kilometers, the particles made that trip over 11,000 times every second. Speed, Jason called out over the enormous noise of the immense machine operating at their hands. This was the indication that the particle stream had now achieved the maximum amount of speed attainable with the power that was available. Particle insertion in 10 seconds. All detection chambers engineered to detect the neutrinos coming from deep space were online, and the recording devices were ready to accept the huge amount of data about to be produced. The 5 calorimeters located in the center of the detection chamber were originally designed to detect particles at different energy states. The sensitivity of these devices were refined more and more to detect incredibly small particles, such as quarks, gluons, and the associated plasma. These collisions, resulting in the release of temperatures over 1 million times hotter than the center of our sun, were incredibly small and incredibly hard to detect. Neutrinos were even harder to detect, since their smallness meant they didn't always hit other atoms. The theory was, with the injection of the massive particle stream from the accelerator, neutrinos would become excited enough to attain an energy level substantial enough to reliably be detected by the new detector system Jason and Dennis had built. Particle insertion in 3, 2, 1, mark, said Jason. At that moment, the immense superconducting magnets guiding the particle streams around the merry-go-round received the commands from the control software to slightly change how they were timed and how they were applying their power. That slight change caused the particle stream to instantly change its trajectory from going around the loop again to going straight into the detection chamber. The particles speeding into the chamber met with another particle stream which had been looping around a sister set of superconducting tubes, only in the opposite direction. These particle streams smashed into each other at a force almost equal to a train crashing into something at almost twice the speed of light. Under these conditions, and under the resulting temperatures, not even subatomic particles making up the very fabric of the universe could hide. The detectors in a standard particle accelerator are designed to ferret out the nature of these particles, allowing physicists like Jason and Dennis to understand how the universe works, and thus how to achieve ever greater and more amazing utilizations of such science. Today, the detectors weren't just looking for the quarks, gluons, and muons of matter, but for the interactions of these subatomic particles with neutrinos. But something went wrong. Immediately before the two particle streams hit each other, the primary calorimeters registered something they hadn't ever registered before. Approximately 100 nanoseconds before impact, the density of the particle stream mass actually doubled. It was as if 2 streams were sent into the detection chamber, but the resulting energy input was what you would expect from 4 streams. For half a second, Jason saw the numbers and instantly thought they may have triggered a chain reaction of some sort. The strange thing was, as soon as the impact occurred, the resulting collision was what would be expected with only the 2 streams. Gigantic release of energy, but definitely not a chain reaction as Jason feared. Jason sat back in his seat, wide-eyed, and reluctantly gave his heart permission to start beating again. Barely audible, he croaked to Dennis, "Did you see that?" "Hang on a minute while I clean out my Pampers," quipped Dennis. It was obvious this had struck him in a similar manner. "What the hell was that?" asked Jason, to no one in particular. "Beats me. Did you get a load of the gamma particle count?" "No," said Jason. "How bad was it?" "Well, that's just it," replied Dennis. "It was 0. "What? How can that be? That's impossible. What's going on here?" "You got me," replied Dennis. "According to the standard model and all experimentation since then, the release of gamma radiation from the temporary disassembling and dispersal of subatomic particles causes the natural release of gamma radiation from the dissolving weak force bonds. This doesn't make sense." Blinking a couple of times, Jason sat forward and said, "Commencing shutdown. Engage power shunts." "Engaging power shunts," replied Dennis. Dennis reached forward and hit 5 keystrokes, commanding the command and control software to begin shunting the power currently coursing through the collider to decrease to 0. "Power level is 0, he confirmed. "Beginning LH reuptake," said Jason. After receiving the commands from the command and control software, large valves opened and pumps started to remove the liquid helium from its position around the superconductors. The pumps took the liquid and errant gaseous helium and compressed it back into storage tanks. It was far too precious of a material to just let go into the atmosphere. "Reuptake complete. Final shutdown complete," confirmed Dennis. Jason and Dennis respectively let out several breaths and then independently realized that the test had failed. Their detectors that they had toiled on for the last 6 months were obviously not working properly. "A bad day," muttered Jason. "Yep," replied Dennis in Jason's ear over the intercom that was still open. Hey, fellow Galimarians, this is Dan Adrian, and I just wanted to say thank you for listening to my book. If you can, please click like down below because it really helps me bring these videos to you and lets me know what you like. Also, if you haven't already, please subscribe and click on the bell so that you'll get notified when I release more chapters. If you have any questions about this or any other of my books, or if you want to know more about what it takes to write a novel like this one, please make sure you leave your question in the comments below. Thanks again. I'll see you soon.